The electromagnetism, the name itself suggests about the term. That is electric plus magnetism. The electric current that produces magnetism. Now, this has discovered by Ørsted, a scientist who discovered in 1820 that when the current is passed through the conductor, it generates the magnetic field around it. So, that is called the magnetic effect of current. In other words, if we give one name to it, so that is electromagnetism. He proved what he had said by a simple experiment. That is known as Ørsted experiment. The experiment suggests that when the copper wire, that is a conductor, is connected to the battery, then the current flows through the copper wire. That current in the copper wire generates the magnetic field around it. Now, if you want to see that the magnetic effect is present outside the copper wire or not, you can place a magnetic compass near the wire. When you place the magnetic compass near the wire that is within the magnetic field, then it shows deflection. Now, on the second part, just change the polarity of the battery you are using. If you are using the battery that is positive upward, negative downward, so change the polarity that is negative upward, positive downward. Okay. After you change the polarity of the power supply, then you see that the deflection of the compass needle is pointing in the opposite direction. That is, if it will point in this direction, that is towards right hand side, then in the case when you change the polarity, it will point towards the left hand side. So that means that when the polarity is changed, the magnetic effect which is created by the current also changes its direction. So the direction of the magnetic effect is proportional to the polarity of the power supply. So this is known as electromagnetism. Now we are going to discuss the magnetic effect created by the various shapes. That is, first by the straight wire, second by the circular loop, and third by the bar magnet. Let's first start with the magnetic effect or the magnetic field lines created by the straight wire. First, let's draw a cardboard. Okay, this is the cardboard which is placed in a horizontal plane, that is like this. This is the cardboard which is placed like this. There is a hole in between through which the copper wire is going to pass. Okay, now pass the copper wire through this hole and connect the two ends of the copper wire with that of the battery, and now regulate your circuit by means of a switch. So this is a battery which is represented by P. This is a key, that is switch, which is used to control the circuit. This is your cardboard which is represented by C. Now, when you on the switch, what happened? The current starts flowing in it. How the current flow? Current always flow from positive to negative side. That is, the current starts flowing in this direction. This is the direction of the current. The current starts from copper wire. Now, the magnetic field is created around this copper wire. Okay. Now, what we will do, that we are going to sprinkle some iron filings on the top of this cardboard. So they are going to arrange themselves in the form of concentric circles. So these are the circles in which these iron filings are going to arrange. How they will arrange themselves? Because the iron filings are experiencing the magnetic force which is created by the magnetic effect due to the current flowing in the copper wire. So these are the magnetic lines of forces created by the iron filings under the influence of the current. Now let's see in which direction they will rotate, whether they rotate in clockwise direction or in anti-clockwise direction. What happens when the current is going up? Then these circles rotate in anti-clockwise direction. So the direction would become like. So remember it, when the current goes up, then the direction of these concentric circles is in anti-clockwise direction. What is this anti-clockwise direction? Anti-clockwise is the direction opposite in which your clock is rotating. You all must have seen the clock rotation, the second watch which is moving continuously. The clock always rotates in this direction. Okay, so this is the direction of the rotation of the clock. This is how the clock rotates. So the direction in which the clock rotates is the clockwise direction. Opposite to this is your anti-clockwise direction. That is, this is your anti-clockwise direction opposite to the clockwise direction. Now let's change the polarity of the power supply. This is the polarity change. Now what happens when you switch on the power supply, then the current start flowing, current from positive to negative. That is, in this case now the direction of current would be this. Again, if you sprinkle some iron fillings, then they arrange themselves in the concentric circles. The direction of these concentric circles are now changed. In the previous one, they are moving in the anti-clockwise direction. And now they have to move in the clockwise direction because the polarity is reversed. Okay, so we can conclude from this diagram that when the current flows in downward direction, then these concentric circles move in clockwise direction. So how this is moving? It is moving in the clockwise direction. This is the movement of the concentric circles. So you have to remember 2 points. When a straight conductor carrying a current moves in upward direction, then these concentric circles are arranged in anti-clockwise direction. When the current moves downward, then these concentric circles moves in clockwise direction. Let's see the direction in which these iron fillings are arranged in a concentric circles. As we have seen in the experiment that the iron fillings are arranged in a particular direction. These iron fillings are arranged in the direction of the magnetic field which is created around the conductor. Now there is a rule associated with it. The rule is used to find out the direction in which the magnetic field is aligned around the conductor. So this rule is called the Maxwell's right hand thumb rule. As the rule suggests, right hand thumb rule, that is, the thumb is used to represent something and the proper hand which we used in this is the right hand. So now I am going to demonstrate you this rule by means of my right hand. So this is my right hand and my thumb is pointing in a particular direction. Now according to this rule, the direction in which the thumb is pointing shows you the direction in which the current is flowing in the conductor. If I point my thumb downward, then that means if my thumb is pointing towards the ground, then the current is also flowing in the conductor in downward direction. So this is how the thumb is representing the direction of the flow of current in the conductor. Now look carefully, the fingers wrapped around this right hand. Now if my thumb is pointing in upward direction, the fingers are wrapped in this direction. You can see the direction in which my fingers are wrapping. So this direction is your anti-clockwise direction, that is the direction opposite to the movement of the clock. So this is called the anti-clockwise direction. That means if the current is flowing in upward direction, then in that case the magnetic field which is created around the conductor is flowing in the anti-clockwise direction. So this is called the Maxwell's right hand thumb rule.